Today we are going to review the 3 different types of functions and their graphs while also identifying the key characteristics and different transformations. The first type of function we're going to look at is a linear function. And before we do anything, we're going to take a look at these vocabulary words so that we know we can fill in these boxes correctly. First word is a 0, and we should know that a 0 is the same thing as an x-intercept. 0 was one of your vocabulary words, and we talked about zeros when we talked about parabolas, but zeros go for any type of functions. And the 0 is the x-intercept, which is where the line crosses the x-axis, and it's also called a root or solution. Your y-intercept is where it crosses the y-axis. Your slope is going to be the m value, which is calculated using rise over run. Domain is all of the possible x values, so it's going to be all the x values of your function, making range all your y values. Again, all of these were vocabulary words that you were tested on, so I'm just making sure that you have mastered these. If you need to take more time to review them, I recommend doing so. Intervals where the function is increasing are going to be where they're going up. Intervals where it's decreasing is when it looks like the function is going down. Function notation when x equals 2, that would be if you had f of x, which is function notation, you would replace x with 2. So you would have f at 2, and we'll go through an example of that here in a second. And last, the end behavior is the change in your y values as x increases. And again, we will go through an example of that. So the change in the y value as x increases. Okay, so the first thing we're going to do is we're going to graph the function f of x equals 2x minus 4. And linear functions you can graph without your calculator. You should be able to plot your y-intercept and your slope. So your m and your b. Your m is 2, which can be written as 2 over 1, and your b is negative 4. So we're going to start at negative 4 on the y-axis. That's your y-intercept. And we're going to go rise 2 over run 1. So rise 2, run 1, rise 2, run 1, rise 2, run 1, all the way to the edges of our graph. If I want to go backwards, I would go down 2, back 1, just like that. I'm going to connect these with a straight line with arrows at the end because it's going to continue on and on and on and on. Okay, so now we're going to fill out these boxes with these different values given our graph and our function. So number 1 is our zeros, which we said our x-intercept is. The x-intercept is where the line crosses the x-axis, and I can see that the line crosses the x-axis right here. So x equals 2, which I'm going to write that as a coordinate pair. I'd go over 0, up 2. This coordinate pair for this point right here would be 2, 0. My y-intercept, you can see from the function or from the graph, your y-intercept is your b value, so it's going to be this negative 4. You could also see that on your graph where it crosses the y-axis is negative 4, and that's going to be over 0, down 4, just like that. Your slope is given to you in your function, and you could see it on your graph. Your slope is going to be m equals 2 over 1, which is 2. To do this, you would find 2 coordinate points. I rise 1, 2, run 1. So these you can go back and forth between all day long. Your domain, your x values. So we are looking at the x-axis. For this linear function, this graph could continue on and on and on forever and ever and ever in both directions, which means your domain is going to be negative infinity to positive infinity, which you could write as all real numbers. Your range is all your y values. So again, this is going to go up forever and down forever. So it's going to be the same, negative infinity to positive infinity. And for linear functions, most times it's going to be all real numbers, unless instead of arrows you have endpoints. And we're going to go through examples of that in the last packet, packet 5. So I'll show you what endpoints look like compared to these arrows that we have on the end for this function. So I'm just going to add, it could be negative infinity to infinity or all real numbers. Number 6 is intervals where the function is increasing. So for 6 and 7, you are going to read the function like a book. So I'm going to read this from left to right. So I'm going to follow my graph all the way from the left-hand side all the way to the right-hand side. And I notice it's constantly going up. At no point am I going down. I'm going up, 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 up. So it's increasing from negative infinity to positive infinity, or all real numbers. When is it decreasing? Well, if it's always going up, it's never, or there are no decreasing intervals for this function. Function notation. So function notation is when you replace the x with a value. So for this value, they said x equals 2. So I'm going to have f at 2 equals 2 times 2 minus 4. My original function when it was f of x was 2x minus 4. But I replaced this x with a 2. So function notation, all you do is you take the number in parentheses and substitute that number, or plug that number in for the variables in your problem. So they replaced x with 2, so I replaced x with 2 here. So 2 times 2 minus 4 is 0. The last one is end behavior, and we briefly talked about end behavior when we talked about exponential functions. And end behavior is what the y values are doing as x is going to infinity. So as x goes to infinity, what is y doing? So as I move in the right-hand direction, my y values are also approaching infinity. This function could go on forever and ever and ever and ever. This would go up forever and ever and ever. So as x approaches infinity, y approaches infinity. You could do that in the opposite direction. As x approaches negative infinity, y approaches negative infinity. So I'm putting negative signs in front of both of those. So as x goes to the left, as I move this way, I'm going down forever and ever and ever, which would be negative infinity. So you have positive infinity up here, negative infinity, positive infinity, negative infinity. So as you move in this quadrant, you're going positive and positive. If you were doing this quadrant, it would be positive and negative. You're positive in your x direction, negative in your y direction, and so forth. So sometimes it helps me to label those so that I know if I'm moving this way, I'm going positive for both my x and my y.